Okay, picture this, an entire year without a summer. I know, it sounds straight out of a sci-fi movie, right? But back in 1815, a volcano in Indonesia, Mount Tambora, erupted with such absolute fury that it literally altered the global climate. I mean, it blasted so much material up into the atmosphere that it blocked out the sun over a massive chunk of the planet. Just the debris from that one eruption caused average global temperatures to drop by half a degree Celsius. So, in this explainer, we're going to unpack exactly what it is that falls from the sky during these catastrophic events, how it actually behaves, and, most importantly, how to survive it.
Okay, let's dive into this. The 1991 eruption of Mount Pinatubo in the Philippines is a wild example of this terrifying reality. You see these colossal churning eruption columns reaching literally miles into the sky. But the immediate aftermath down on the ground, it's just as jarring. Look, it's the middle of the day, but the sky is pitch black. A massive volcanic plume can literally block out the sun and turn day into night, forcing thousands to flee under this terrifying dark rain of debris.
So to really understand what's plunging these places into total darkness, we need to talk about a pretty crucial scientific term, and that is Tephra. Tephra is basically the overarching catch-all name for all the material raining down from the sky. Every single piece of volcanic rock, every shard of glass, every chunk of lava that gets violently blasted into the air by an explosion or carried up by the searing hot gases of the eruption column. Simply put, if it comes out of a volcano and goes up into the sky before falling back down, it's Tephra.
Now you might be thinking of those terrifying superheated avalanches of gas and rock, pyroclastic flows. It's really easy to confuse the two, actually. But while pyroclastic flows hug the slopes of the volcano as they race downward, Tephra behaves completely differently. Tephra falls directly from the sky. It completely skips the slope. Because it gets shot so high up into the atmosphere, it can travel hundreds or even thousands of kilometers through the air, just catching a ride on wind currents. Which means Tephra can devastate a vastly larger landscape than a localized pyroclastic flow ever could.
And that brings us to exactly how this stuff coats the landscape. It's really fascinating. The wind actually acts like a giant natural sorting machine. Volcanologists call this a winnowing process. As the eruption column blasts material upward, the prevailing winds grab hold of the plume. The heaviest stuff, like those massive ballistic projectiles, just can't be carried very far, so they drop right out of the cloud close to the vent. But the finer, lighter stuff, like ash, the wind carries that exponentially further away. So the landscape gets painted with this mantle of ash that slowly thins out the further downwind you go.
Because Tephra comes in so many different shapes and sizes, scientists classify it strictly by diameter, and the categories are actually super straightforward. If the fragments are really fine, less than 2 millimeters across, that's your ash. If they range from 2 up to 64 millimeters, so roughly the size of a pebble up to, say, a tennis ball, we call that lapilli. And finally, anything larger than 64 millimeters across falls into the heavyweight division, volcanic bombs and blocks.
Now, what's really interesting here is the fascinating distinction between those massive projectiles, the bombs and the blocks. Both of them are those big heavyweights over 64 millimeters that shoot out of the vent at steep angles like literal cannonballs, but their origins are totally different. Volcanic bombs actually come from fresh molten magma. Because they're liquid when they get ejected, they get these smooth, aerodynamic, and honestly kind of weird shapes as they cool flying to the air. Volcanic blocks, on the other hand, are just shattered pieces of the already solid vent wall. They were solid before the explosion even happened, so they stay rough, angular, and have really sharp edges. Moving down a size class to lapilli, we get some truly marvelous formations. Depending on the chemical makeup of the lava and how exactly it cools, you get wildly different things falling from the sky. For instance, rapid cooling of liquid basaltic lava mid-air can create these perfectly smooth, teardrop-shaped glass fragments called Peely's tears. If the wind is strong enough, it can actually spin that same molten glass into long, thin strands known as Peely's hair. Then you've got pumice and scoria. These happen when vigorous gases escape from the magma, foaming it up like a sponge. In fact, pumice traps so much gas it's incredibly light, so light it can actually float on water. How wild is that?
All right, so we've talked about the fiery flying cannonballs, but let's shift gears to the finest material, volcanic ash. At first glance, it might seem like the least intimidating hazard of an eruption, right? Just a fine powder quietly drifting down. But consider this completely counterintuitive fact. Would you believe that the main threat of fine falling ash is actually its weight? It's true. It's a silent, creeping danger that catches so many communities entirely off guard. You see, when we hear the word ash, we naturally think of a campfire, soft, flaky, burnt wood.
But volcanic ash is not burned wood. It is literal, pulverized rock and glass. And because it's solid rock, it is incredibly heavy. Just a thin layer settling on power lines can literally snap them in half. A mere 10 centimeters of the stuff can completely destroy agricultural lands by burying crops and stunting vegetation. But the real nightmare scenario? That happens when this rock dust gets wet.
Take a look at the devastating aftermath at the Subic Bay Naval Base following that 1991 Pinatubo eruption. It's just widespread structural failure. What happened was, during the eruption, heavy rains from a passing storm saturated the falling ash. That wet, pulverized rock became so immensely heavy that the roofs of residential units and big industrial buildings simply caved in under the sheer crushing weight. It's incredibly tragic, but most of the deaths reported during the Pinatubo eruption weren't from flying lava or explosions at all. They were actually caused by roof collapses exactly like this one.
And this brilliantly illustrates the multi-layered threat of Tephra. Because airborne fine particles don't just crush buildings, they physically attack the human body. On the respiratory side, inhaling fine ash seriously exacerbates lung disease. But even more terrifying is silicosis, which is severe scarring of the lungs caused by inhaling the microscopic crystalline silica in the ash. Then you have the ocular threat. These tiny shards of glass cause conjunctivitis and can literally scratch the corneas right on your eyes. And mechanically, the reduced visibility and slippery roads lead to severe auto accidents, completely compounding the trauma of those collapsing roofs we just talked about.
And the cascading failures don't stop there. The secondary hazards of Tephra are absolutely devastating to both infrastructure and the environment. Remember those volcanic bombs? They can reach 1100 degrees Celsius, instantly sparking fires the second they hit vegetation or buildings. Then you've got the fine ash, which is notorious for clogging air filters in industrial machines and can literally stall jet engines mid-air. Plus, airborne ash turns day to night, dropping visibility to absolute zero. Oh, and the Tephra itself? It's often coated in toxic gases, acid aerosols and salts that poison local water supplies. Finally, once all that ash settles and hardens, it acts like concrete, totally eliminating water absorption and triggering massive floods and accelerated erosion. It's the whole shebang.
So knowing all of this, the absolute critical question becomes, how do we actually survive it? Well, the key to surviving a Tephra fall is meticulous preparation and knowing exactly what to do at every single stage of an eruption. Let's walk through a definitive safety guide on how to protect yourself, your family, and your community before, during, and after a volcanic fallout event. Preparation has to start long before a volcano even wakes up. First off, local governments need to establish shelters far beyond the primary projectile zone. I mean, you just can't build a bomb-proof shelter near the crater. The impact energies are way too high. For those living further out, engineering is your best friend. You'll want to cover any crater-facing windows with heavy corrugated iron sheets to deflect those smaller hot fragments. If you live in an area prone to ash, your roof absolutely needs a steep pitch to naturally stop that heavy Tephra from building up. And personally, long before an emergency strikes, you need to stock up on high-efficiency dust masks.
Now, when the sky actually starts falling, your respiratory health is priority number one. You need to wear protective clothing and those high-efficiency dust masks. If you're caught without one, improvise. Dampen a handkerchief or fabric mask with water that'll really help filter out the larger ash particles. You need to shelter in place, making sure all doors and windows are firmly closed to seal out the ash and toxic gases. So the crucial point is this: you cannot just hide and wait it out. As we saw with Pinatubo, you have to continuously and carefully clear the Tephra from your roof as it builds up to prevent a catastrophic structural collapse. And if you absolutely have to drive, maintain a huge distance between vehicles because those roads are going to be incredibly slick and visibility might be essentially zero.
Once the eruption finally stops and the ash fall ceases, the danger is far from over. Post-fall cleanup requires some incredibly careful procedures. Your first priority is to stabilize or remove the Tephra from the ground. Why? Because the wind or just passing cars can easily kick that dry ash right back up into the air. This completely restarts the respiratory and ocular hazards in a process known as reworking. When you're cleaning, handle the ash in open, well-ventilated areas and continuously wet the dust with water to trap it so it doesn't go airborne again. And throughout this entire cleanup, strictly wear goggles or regular eyeglasses. Do not, under any circumstances, wear contact lenses. That fine silica will get trapped underneath and severely scratch your eyes.
As we wrap up, I want you to consider this.
We've seen how volcanic fallout is so much more than just a localized hazard. It's this incredibly dynamic threat, ranging from massive flying chunks of molten rock to microscopic shards of glass that can travel across continents. If a single eruption like Tambora or Pinatubo can literally plunge the day into night and physically alter global temperatures, we have to ask ourselves, how structurally and logistically prepared is your community for the silent, crushing weight of the next major ashfall? It's a pretty heavy reminder of the raw power of our planet, and why understanding that power is absolutely our very best defense. Keep exploring, keep learning, and as always, stay prepared.